Welcome back to part 2 of anti-differentiation by parts. Oops, don't have my pen selected. Let's do a slightly more complicated function. And I'm going to let u equal x squared. And just by the way, anytime you have a power of x, that's probably going to be your u, because every time you differentiate, it's going to go down by a power, and so that's helpful. And so dv will be equal to e to the x dx. And there's another tip, is that it's helpful to choose dv to be something you know the antiderivative of, because we now know that du is equal to 2x dx, and we know that v is equal to e to the x, which means that my anti-differentiation by parts, let's go ahead and write the formula up at the top, uv minus integral of v du. My anti-differentiation by parts will give me x squared e to the x minus the integral of 2x e to the x dx. Well, hey, you know what? This looks to me like another anti-differentiation by parts. So I'm going to make u equal to 2x. I'm going to make dv equal to e to the x dx. Very simple and straightforward. Du is 2 dx. V is e to the x, just like it was. And this now becomes x squared e to the x minus, now be careful, parentheses, uv, 2x e to the x minus the integral of v du. So this just becomes 2e to the x dx. And I don't have to put the constant on, in case you're wondering, until I get to my last one. The constant doesn't do anything until I'm done here. So now I know the antiderivative of 2e to the x. It's just 2e to the x. So this becomes x squared e to the x minus 2x e to the x plus 2e to the x plus a constant, and I have just found the antiderivative of x squared e to the x dx. Something I could never have found using what we knew before today. All right, so I'm going to close this example, and we'll come back with an initial value problem. Thanks for watching. Hope you learned something.